Now let us see the interacting and non-interacting processes. You consider a level process. This is the level process of two capacitors. This is tank 1. This is tank 2. Its area of cross section is A1. Here area of cross section is A2. The inflow rate to the first tank is QI. Outflow rate of the first tank is Q1. Outflow rate of the second tank is Q0. The level in the second tank is H2. The level in the first tank is H1. Q1 is B1 times H1, square root of H1. This is the outflow rate from the tank 1. Outflow rate from the second tank is B0 times square root of H2. Here, the outflow rate of first tank is B1 times square root of H1. The outflow rate of second tank is B0 times H2. But the outflow rate of first tank is independent of level in the second tank. Similarly, the outflow rate of second tank is independent of level in the first tank. That's why it is called non-interacting process. But on the other hand, the tanks are like this. Same level. The inflow rate to the first tank is QI. The outflow rate from the second tank is Q0. The level in the second tank is H2. Similarly, level in the first tank is H1. The flow rate from first tank to second tank is Q12. Here, Q12 equal to B12, some constant times square root of H1 minus H2. Let us assume that H1 is greater than H2. Q0 equal to B0 times square root of H2. Here, any change in H2 will affect the level in H1 because if inflow rate equal to outflow rate, that is QI equal to Q12, then only the level in H1 will be constant. If any change in Q12 will affect the level H1, similarly, any change in QA also will affect the level H1. It is the Q12 is function of H2. That's why any change in H2 will affect H1. That is called interaction. But it is not so in this case, the first case. The first case, it is not so. That's why it is called non-interacting. But here, it is interacting level process. If you consider any change in H2 will affect H1, but any change in H1 will affect H2. Yes, that also will change the inflow rate. That's why these two are called interacting level process. The interacting level process. Another example for interaction, if you consider the closed loop of a stirred tank heater. Here in this heater, two variables has to be controlled. One is this level has to be controlled. For that, a level controller is there that regulates the outflow rate, F. The feed inflow rate is Fi and feed inlet temperature is Ti. Temperature inside the process is T. To control this T, it is endothermic. Sorry, it is an endothermic thermic process. So heat will be supplied by the steam. Heat will be supplied by the steam. In this case, suppose there is, let us assume that initially level H and temperature T are at desired level. Desired level means it is at set point. Let us assume level as well as temperature is at set point. If any change in Ti will affect the temperature, that's why this temperature controller will regulate the steam flow rate, will regulate the steam flow rate so that the temperature will be controlled. Anyhow, it will not affect the level. It will not affect the level. On the other hand, if any flow rate changes, inflow rate changes, there will be a change in level. That's why the level control will take necessary action. Any change in level will affect the temperature. That's why if H changes, that will in turn affect T1. That's why H interacts with T, but T doesn't interact with H. One-way interaction. H interacts with the T, but T doesn't interact with the H. This is called a one-way interaction. But here it is a single process. It is a single process. But instrumentation engineer's point of view, these two can be seen as two processes. One is temperature process and another one is level process. The instrumentation engineer's perspective, these two can be seen as two separate processes, but they are interacting. One-way interacting. H is interact with the T, but T doesn't interact with the H. But for a chemical engineer, it is a single process. It is a single process interacting variables. As far as chemical engineering is concerned, two variables T and H are interacting in a single process. In a single process, H is interacting with the T, but T doesn't interact with the H for a chemical engineer. These two are variables for a single process. But for an instrumentation engineer, these two can be seen as two separate processes. But the process H is interacting with T. That way, instrumentation engineer can see as two processes. Two processes. As far as instrumentation engineer is concerned, each loop is a process. But it is not so for a chemical engineer. Here, another example for interaction, a CSTR is considered. The CSTR, the concentration of CSTR, effluent concentration, CA of the CSTR, as well as temperature has to be controlled. To control the temperature, it is an exothermic process. It is an exothermic process. That's why coolant is used to remove the heat generated by this process. This temperature controller will remove the heat. A composition controller is there, CC is there, that will control the composition. For that, it will control the feed flow rate to control the composition concentration, CA. CA has to be controlled. For that, it adjusts to the feed flow rate. Here, any change in, because of, suppose let us assume that there is a change in CAI, concentration, composition of the inlet changes, That's why there will be a change in CA that has to be adjusted by adjusting the flow rate, inflow rate. That will taken care by CC. Because of change in flow rate, there will be a change in temperature. So therefore, the loop 1, control loop 1 and control loop 2 are interacting. On the other hand, if any change in inlet temperature Ti, that will affect the process temperature T. So that the coolant has to adjust its flow rate to adjust to T. That change in T will affect the composition. Therefore, temperature interact with composition. Similarly, composition interacts with temperature in bidirectional interaction. Here also, instrumentation engineer will see as two separate processes. One is a temperature process. Another one is composition control process. But they are interacting each other. But for a chemical engineer, it is a single process with the two variables, temperature and composition, both are interacting.